Okay, so in this video, we're going to cover everything that we need to know about imaginary and complex numbers. So starting with, what are they? What are complex numbers? How do we perform arithmetic with them? And how can we factor with them? Right. So first, let's answer the question, what is an imaginary number? To put it simply, it's a non-real number. Okay, and where they arise is simply from taking square roots, right? So, for example, this first equation here, x squared plus 1, if I go ahead and solve this by subtracting 1, we already see we're going to have a problem because I'm going to have to take the square root of both sides. So that means x is equal to plus or minus the square root of negative 1. And this right here is the imaginary unit number. Okay, and we use the letter I to denote this number. Okay, so an imaginary number is simply, there's only one, it's the square root of negative 1. Okay, now let's get a little more complicated. So let's look at where another one would arise. So this equation. So this one's much like the first one we just saw. If I subtract 25 from both sides, I see that I'm going to end up with x squared equals negative 25. And we're going to run into a similar problem as previously there in the green. We're going to see that x is equal to plus or minus the square root of negative 25. And if we were so bold as to go ahead and factor this, we could say x is equal to plus or minus um, 5 times the square root of negative 1. Or, simply put, equal to 5 times the imaginary unit I. Okay, so in a nutshell, that's all imaginary numbers are. Here we see just a few examples that we can go through. I'm only going to do the odd ones here on this video. So square root of negative 9, we can say that that is 3i. Uh, Square root of negative 75, right? Well, of course, we can say that this is basically, square root of 25, square root of 3, square root of negative 1, right? So I really broke that one down. And that's going to give me 5i square root of 3. Okay, and if we're being really picky, if we want it in the form bi, we would say 5 square root of 3 times I. bi. Okay, and last one, square root of negative 150. So we could use 25 there again. 4, 5, 6. Yeah, so we could say that this is square root of 25 times the square root of 6 times the square root of negative 1. So 25 times 6 gives us 150. And of course, times negative 1, that's where we get the negative from. So when we simplify that all out, we would have 5 square root of 6 times I. Or you might see it written another way, 5i square root of 6. Okay? So here's an extra credit opportunity. Obviously, I'll show you this in class. If you want to go ahead and freeze this or pause it rather and take a screenshot, feel free to do so. Okay, so now let's answer, well, what are complex numbers? Right, so here we've got some long text explaining what that is. I'll let you pause this for a minute and read that. But all it really is saying that imaginary numbers, well, complex numbers, are numbers that have imaginary parts, constituents, and they also have real constituents, right? So, for example, like we see on this first one here, we can say, if we simplify this, that we've got negative 3 plus 6i. Okay, and now we have the form a plus bi as prompted here, right? And we can continue this way. So here I can say I've got 5 minus, that would be 2i square root of 2. Or again, if we're being picky and we really want it to be in the form a plus bi, 5 minus 2 square root of 2, that would be the square root of 8, times I. Okay, so not going to and well, I guess I should go ahead and go into this example just in case. So 12 plus 3 times the square root of negative 50. So when we factor this one out, when we really break it down, this is what we'll end up with. If I start breaking down the square root of negative 50, of course, I have the square root of 25 times the square root of 2 times the square root of negative 1. Okay, so what I've really got to simplify this all out is 12 plus 15 square root of 2 times I. This here is 5. 5 times 3 gives me the 15 that I got here. Can't simplify square root of 2. And of course, square root of negative 1 became I. Okay, so in a nutshell, that's how complex numbers work. We also have the following, induction that would follow here. Okay, so another special thing about I is that when you square it, right, I squared is the only number that when you square it, you get a negative result. Okay, and I'll put it simply, it's because if I have, this all squared, we can say that they're inverses and undo one another, and we're left with negative 1. But that's not really what it comes down to. It actually comes down to something that happens on the complex plane, and I'm not even going to try to explain that in this video. Um, you can learn all about that if you just YouTube uh, y is I squared negative 1, if you're that curious, right? But all it comes down to, so I is just equal to I, or the square root of negative 1. I squared is negative 1. I to the third, well, that's I squared times I. So I squared to the, or my bad, I to the third would be negative I. And we can see how this is going to work. I to the fourth, well, that's I squared times I squared. So that's negative 1 times negative 1, which is just positive 1. Okay, I to the fifth, and you can see where we're going with this. I to the fifth would end up just being I. Okay, and that's because I would have I squared times I squared. Well, we already know that's just going to be positive 1. And then times one more factor of I. 1 times I just gives me I. Okay, so it kind of comes down to positives or negatives result from where we see um, evens or odds, right? And it's going to follow this pattern. So we either get I, we either get negative 1, we either get negative I, or we get positive 1. And then the pattern just starts all over again, every fifth degree of I. Okay, so let's ignore this. We're not going to mess with that. Okay, and then EQ3, how's arithmetic done with them? So it's done pretty much the same way it's done with any number. So for example, here we've got some addition of two complex numbers. So 5 plus 4i plus negative 2 plus 3i. So we don't need these parentheses because nothing's being distributed into them. So I can go ahead and drop them. Plus negative 2 plus 3i. So we're just going to combine like terms, literally. That's all we're going to do. So we end up with 3 plus 7i. Okay, so this 5 right here combines with this negative 2, gave me the 3, 4i, 3i, 7i. Okay, so not anything too significant there. Not going to mess with those fractions. Okay, so right here we do see an instance where we will need the parentheses, right? So these parentheses are going to get distributed into here. So we're going to have 8 minus 5i minus 3i, not 3i, just 3, minus 3 minus 5i plus negative 5 plus 10i. Don't need those parentheses there. Okay, so now it's just again a matter of combining like terms. 8 minus 3 is 5, right? 5 minus 5 is 0, so that's just gone. So we have 0 for A. Negative 5i, negative 10i, and we get 0 again. So 0 plus 0i. Okay, so that was a fun example. Okay, and now let's look at this last one here. So here we see we're multiplying, right? And all that's going to happen is we're just going to FOIL like we normally would. Okay, so first uh, outer, oops. Oh my goodness, what is the matter with me? Okay, that would be 42i. So minus 42i. And first outer inner, so plus 20i. And last, negative 35i squared. Okay, so we combine like terms. So 24 can't combine with anything, so that guy's just going to sit here. Okay, negative 42i, positive 20i. That leaves us with negative 22i. Okay, this right here is where it gets interesting, right? So we said previously that I squared gives us negative 1, right? So this means this negative 35 becomes a positive 35 because it's 35, negative 35, times negative 1. Okay, so that means we're going to end up with, for a final answer, 59, right? Because 24, 35, 59 minus 22i. And that would be our final answer, a plus bi. Okay, and last one, complex conjugates. So complex conjugates are basically pairs of numbers where we have a differing sign of operation between the two. So a plus bi's conjugate, a plus bi's conjugate would be a minus bi. Okay, and what's cool about that is if you ever uh, have a complex conjugate being multiplied together, like we do right here, okay, the product will always be a sum of squares. Okay, so this example right here is just asking us to identify the conjugate and find their product. So our conjugate of 2 plus 3i would be 2 minus 3i. Okay, and again, we know when we multiply a conjugate pair, a complex conjugate pair, we always get a sum of squares. So that's going to end up being 2 squared, a squared, plus b squared. Oops, getting ahead of myself. Okay, and that of course would just be 4 plus 9, which is 13. Okay, and if you want to take the time to FOIL this out, I mean, by all means, feel free to do so. Okay, last one that we're going to do. So conjugate pair of this guy, all we do is change the sign of operation in between the two terms of the binomial. So right here we have a instance of multiplication by a pair of complex conjugates. That means we're going to get a squared plus b squared. So negative 5 squared, that's still just positive 25, plus 2 squared, which is still just 4. Our final answer would be 29. Okay, and then we have complex quotients. Okay, so complex quotients, if you remember, right, if we ever have an irrational denominator, well, we have to fix it by multiplying top and bottom by the irrational number, right? That way, we end up with, a number that's not so horrible, right? So same idea, we can't have, not so much that we can't have, but we don't want irrational numbers, nor do we want imaginary or complex denominators. Okay, so right here, first of all, 1 over I to the third power, right? We know from way back here, I to the third power is just negative I. Okay, so we're going to go ahead and take advantage of that. 1 over negative I. Okay, and I'm just going to multiply top and bottom by I to get rid of our complex or imaginary denominator in this case, right? And we end up with I over negative I squared, which is going to just be I. Okay, and I guess I should break that down. So we would have I over negative 1, which is just I over 1. And it's redundant to say that, so we say our answer is just I. Okay, Another example. Okay, so we have a complex denominator here, right? And we know that we can't just multiply by the same thing. But if we multiply by a conjugate, right? If we multiply by a conjugate, so if we take a complex number, multiply by its conjugate, we get a real number for the product. Okay, so that's exactly what I'm going to do. I'm going to multiply top and bottom by the conjugate of my denominator, so 2 minus 3i now. And what I do to the bottom, I must also do to the top. Okay, so underneath, we're just going to have 2 squared, which is 4, plus 9. So we're going to end up with just 13 in our denominator. And then here, of course, we're going to have 4 minus 5i being multiplied by 2 minus 3i, in which case we're just going to FOIL. So that's going to give me 8 minus 12i, right, minus 10i, and plus 15i squared. I'm going to try not to skip too many steps so I don't confuse anyone. Okay, so this 15i squared here, right, is going to become 15 times negative 1 because I squared is negative 1. So really, this is a minus 15. So we have 8 minus 15. That gives us negative 7 minus 12i minus 10i. So I guess I could go ahead and combine those. So minus 12 minus 10, that's minus 22i over 13. And if we want it in the actual a plus bi, we're of course going to have to break this down into negative 7 over 13 minus 22 over 13 times I. Okay, that would be our final answer. And let's do one more example of this. We'll do this one right here. So again, I'm going to multiply by the conjugate of the denominator because you can't have a complex denominator, so 1 minus 5i. And that's going to leave me with 1 minus 3i being multiplied by 1 minus 5i. All of that over 1 squared plus 5 squared, so 26, is equal to, so 1 times 1, that's 1. 1 times negative 5i, that's negative 5i. And we have negative 3i times 1, so minus 3i. And then we have, so that's going to be positive 15i squared, so minus 15 because of the I squared. Start simplifying, so 1 minus 15, that's negative 14. And then that is over 26. And then we have minus 8i, so minus 8, whoops, minus 8 over 26, and then that's all times I. And then, of course, we can reduce that. So we can say that's negative 7 over 13 minus 4 over 13, all times I. And that would be our final answer. So that does it for this video. Like always, let me know if you need anything. Otherwise, goodbye.